Thank you all for joining. 9 o'clock on the second day, so I imagine people have been out drinking and partying last night, which reminds me, the JBoss party is tonight. I have lots of invitations here. You will need an invitation. Suddenly got quite loud. Come up and get one afterwards if you haven't already got one. So, my name is Mark Little, VP of Engineering at Red Hat, where I have the middleware and application services teams report into me. So that's things like Wildfly, Camel, our Kafka effort, Quarkus, our OpenJDK team. So the title of this is Java in the Cloud. And it absolutely is about Java in the cloud, but there's also other things I want to touch on here. Essentially, what I want to talk about is probably more, we probably should change the title because it's more reflective of what's actually in the abstract. So hopefully most of you come here for what's in the abstract, not what's necessarily in the cloud. And I'm going to also, not what's in the title. I'm going to talk about some problems, some of which are cloud related, but some of which aren't, where I think Java and people in this room and our communities have a key role to play. Now, before I start, I actually want to dedicate this talk to Bob Lee. I don't know, some of you may have heard of Bob. Some of you may have inadvertently used some of the things Bob had been working on, like Google Juice. Bob was a friend that I came into contact with when we were working on EE6. He helped influence things like CDI. And unfortunately, Bob was killed a few weeks ago in San Francisco. So this is the first talk I've had a chance to give publicly, and I thought I'd at least try and have my say and give a dedication to Bob. Okay, so moving on. I don't know, I'm looking around the room and I don't want to be ageist here, but there's a number of very young people in the room and some more mature people in the room, okay? So some of the very young people in the room may not necessarily know all of the history behind Java, but quickly short-circuiting it, I will say that back when Java first came on the scene in the late 90s, this was kind of your typical way of doing things because Java was developed to essentially spin up a JVM, grab all of the resources that were around, and in many ways, isolate you as a developer from the operating system. So in fact, over the years, Java became more and more of an operating system. And if some of you are old enough to cast your minds back to remember the Java station from Sun, really cool looking box, it's kind of dead on arrival, but its idea was the operating system was just enough to boot up the JVM. But essentially, this is how we built Java applications, large and small scale Java applications for decades. You had your operating system, but then you had your JVM, you had your app server. Doesn't necessarily have to be an app server, but just in this case, typically the environment in which your business logic is deployed. And then you have your apps or your business logic. But you typically had one of these per machine. If you were lucky and you had a very powerful machine, you might be able to get a couple of them running at the same time. Then, from the 2010s onwards, coming off the back of service-oriented architecture, we start to see microservices. So breaking of these monoliths down, because monoliths were apparently bad. I don't actually believe that. I think there's a lot of good monoliths out there. And if you want to decompose your monolith into microservices, you should do it in a reasonable way. If it's not broken, don't fix it, okay? Because you're probably going to introduce all new types of problems as you move to a microservices architecture. But essentially, we have seen over the last, God, where are we, 2023 now? Over the last 10 plus years, we've seen this migration away from your typical monolithic architecture to multiple independent services that collaborate together to perform the same kind of work. And there are advantages and disadvantages. But this migration to microservices came on at about the same time as we were starting to see a lot more use of public cloud. For a while, public cloud was that thing that other people did. But then, around about 2011, 2012, we really started to see people using it more in enterprise deployments. Now, before I get to the next few slides, I did want to spend a little bit of time just saying, again, one of the things that we often hear about Java, the language and the frameworks is, oh, it's been around for so, so long. It's definitely yesterday's technology. But whilst that might be true to a degree, as in it's been around for a long, long time, it has advantages of the fact that it's been around for a long, long time. It has been deployed in lots of different environments, lots of different use cases. And there has been, I don't know, I'm going to say millions of people hours have gone into the development of the ecosystem and the JVM and the language. It has evolved a lot over those 20 odd years. And Java today, it's optimized a hell of a lot, pardon my French. The traditional footprint that we saw before is optimized for throughput. If you spin up a JVM today with an application server, even something like Tomcat or Wildfly, you can get very, very, very good throughput these days for the JVM and Java itself without making any changes to what you get out of the box, what you download, because it has been optimized so much by developers from IBM, Oracle, BEA in the past, Red Hat, etc. It's a very, very rich language as well. It was one of the first languages back in the 90s that allowed you to dynamically adapt at runtime what was happening in your application. Prior to that, you had to play around with dynamic link libraries if you were in C or C++, and that was fraught with memory leaks and null pointer exceptions. Java with class loaders made that so easy, and in some ways maybe too easy, but we'll come to that in a minute. Then when we moved to microservices and the cloud, we after a few years, we started to see Linux containers became like the default. Then we started to see coordination mechanisms come up, like Apache Mesos and Kubernetes. Kubernetes is now essentially the de facto standard. But Kubernetes started to present a problem to Java, because despite the fact that Java had been around for a long time, ignore my bouncing dock, had been around for a long time and is a very, very dynamic language, that's not the model that Kubernetes espouses. So for those of you, hopefully everybody in this room has heard of Kubernetes, whether you've played with it or not is a different matter, and hopefully everybody has heard of Linux containers. What Kube does with Linux containers is it essentially assumes an immutable architecture. So it, unlike Java, where, as I said a few minutes ago, you can change things at runtime. You do not have to shut down your application server or your application. You can literally, spin out your JMS implementation and spin in a completely new one, and hopefully it'll just work, but typically it does. Kube doesn't really want you to do that. If you're making changes to the running image, you're doing it the non-Kube way. What Kube would say is, you want to make a change, you create a completely new Linux container image. You push that out to the repo, and the next time you want to spin up, or Kube wants to spin up something because of load balancing, it gets that new image. You don't change the dynamic image. Sorry, you don't change the image dynamically. So that's kind of at odds with the Java model. And it was about this time, 2016, I don't think Red Hat was, well, I know for certain Red Hat wasn't alone in this, that these problems that Kubernetes was throwing up, and cloud in general, were also starting to be big challenges for Java going forward. So we literally had customers coming to us and saying, we love Java. We've got globally 6,000 Java developers. But although cloud is cheaper than our back office private cloud, or public cloud is cheaper, it's still not zero cost. And as we try and cram more and more applications onto instances running on EC2, we're finding it really hard to get that cost benefit that we get with something like Go or Node because of the model that Java has. And app servers were part of the problem as well, but not really the only problem. So we literally had customers saying, we're probably going to have to start thinking, as we migrate from our monoliths to our microservices, that we migrate from Java and we go to a Go or a Node or something else. And this, in some ways, is also reflected in there's a link down the bottom, 2018 serverless.com analysis that they did. So back in 2018, they were finding that from a language point of view that would typically use to build logic that was running in a serverless environment like Lambda, that most of that was JavaScript with Node, and then Python and Go, and Java was on a par with Go. Funnily enough, I think that might be because back then Go was still seen more as the language for building things like Linux containers. It's not necessarily seen in 2018 as the language for developers building applications that we would use. So this is a big problem for Java. And just, this is typically the way in which, it says circa 2018, but I guarantee if you're a Java developer, you're pretty much doing most of this today anyway, where you would do very little binding of your interface to implementation at build time. You download your Maven, your jars from Maven or whatever. You decide what versions you need. You build your application. You leave these kind of, like I said, the bindings, for instance, and configuration to runtime, because you might want to change it. You might want to say 2 hours after your application is run, you know what, I'm not actually going to use that version of JMS. I'm going to use this version of JMS, or I'm not going to use this transaction implementation. I'm going to use this one. And I want to leave that to as late as possible because I don't know as the developer what the business logic is going to need. So we leave a lot of that to runtime. And necessarily that means that this has an impact on startup time and memory footprint, because if you're going to have 5 or 6 different JMS implementations that you might want to choose from, you're going to need to make them all available. Otherwise, you'll get an exception. So this was also part of the problem. Again, this immutable versus non-immutable. The Kubernetes native way, as I said, because of immutability, would be this. Would be essentially do as much of it as you can at build time. Make those decisions about which JMS implementation, which transaction service, which caching implementation, whatever. Do it at build time. Don't do it at runtime. So you've made those decisions, and if you need to change them, create a completely new image. That's the way that we should be doing things from a Kube way. Now, hopefully, you'll all have heard of Quarkus. There's some folks at the back sitting around with Quarkus shirts on. Quarkus is not the only thing that has kind of tackled that problem that I've mentioned just before, but I'm going to talk about it because it's the Red Hat way of tackling it. But essentially, Quarkus came out of that series of problems. The traditional Java way of doing things, the grab all the memory and all the machine resources, don't give them up until the application is gone. Be ultra dynamic, not mutable. Quarkus took a very different perspective. It was, what do we do in a Kube native world to ensure that we have Java and our frameworks be immutable and be tailored specifically for deployment to Kube. And so we released it officially beginning of 2019. There was some skunk works going on in 2018. It's now on. So when I created this slide, it was 2.16.6, probably 2 versions after this by now, because the team released extremely quickly, which is another cloud native way of doing things. You don't wait for like 12 months to put out a new release. So a lot of what has gone in from a Java development point of view over the last 3-4 years or so in Quarkus, and as we'll see in Java, the language and the JVM, from a Red Hat point of view, has been focused on trying to tackle that problem. But like I said, there are other implementations from other vendors and other communities that are doing exactly the same thing. It wasn't just us that recognized the problem. So I'm sure there were some Quarkus talks yesterday, and there's probably some Quarkus talks later on today. So I'm not going to talk an awful lot about this, but just for those of you who haven't looked at Quarkus or weren't at one of my talks last year, just to give you some examples, memory footprint. So Quarkus works in 2 ways. It works in pure OpenJDK mode, no changes to the JVM required at all, but changes to the way in which you build, if you remember that slide previously. And then it works in a native way, so it relies on GraalVM, which I'll have a slide for in a minute. And there are pros and cons of both of those. So from a memory footprint point of view, we have our traditional cloud native stuff stack in gray. This application that we are demonstrating here it's not just a hello world. It literally, it's using REST Easy and JPA, so it does a database access, uses transactions, and then sends a result. On the traditional cloud native stack, the memory footprint, 136 meg, not that bad. Particularly if you think back 15 years or so to, when you would struggle to get, even an application server running in, less than 500 megabytes of memory before you even had applications deployed to it. Quarkus with JVM mode, so this is not the native one, that memory footprint is down to 73 meg, so 50% reduction. Then if you compile it, it goes down to 12 meg, so less than 10% of the memory footprint of the cloud native stack. But going into that, both of those is making those decisions, the bind time decisions at build time, not at runtime. That's memory footprint, faster startup time, so 4.3 seconds to return the result, to actually start up and be able to field the request, not return the result. 4.3 seconds, Quarkus with non-native, less than a second, and Quarkus when it's compiled, much less than, a tenth of a second, 0.016 seconds for those of you who can't see at the back. So this really does start to put Java and frameworks that are developed like this back as first-class citizens in the cloud and the Kubernetes world. And in fact, when we first demonstrated this to those customers who were concerned and thinking about going to Go, several of them, literally, as we demonstrated the alpha version, so we hadn't even released it officially, they said, look, this is sufficient for us. If you guys are going to go forward with it and back it, we will not be moving to 6,000 developers telling them to go and learn Go and re-implement stuff. We'll stay with Java because that's a lot of time saved that we can take that skill set that they've built up over many, many years and put it directly onto this. I'll just briefly stick up this slide. So this is just some success stories. You can find these success stories in much more detail on the Quarkus website. If you go to quarkus.io and look at the user story section, you'll find these and many, many more there. But we've had like Vodafone, Vodafone Greece and Lufthansa, and big and small companies literally give us these testimonials for what Quarkus is doing. And some of them use the native aspect, but some of them don't. Some of them are happy enough with just continuing to work on OpenJDK and not actually go all the way down to compiled Java. And you might have seen this briefly on 2 slides ago, but essentially this shows you that whereas the previous one of these that you saw had Go and Node almost neck and neck, and then you had the traditional native stack here, which was the problem. Now with Quarkus, with those startup speeds and those memory footprints, it is on a par with Go. So we think from a Red Hat point of view with Quarkus, but as I keep saying, other implementations are available. We think we've, if not fully addressed, we've 90% addressed that concern that people have with Java running on Kubernetes and on the cloud. I mentioned this just before. So one of the helps that we have is from a project called GraalVM, which comes from Oracle Labs. That we've had a really close partnership with Oracle Labs on Graal for 4 years or so. We're on their steering committee. We help them with use cases. They help us as we evolve Quarkus. But essentially, Graal is a big project, so it's not everything that they do that we use from a Quarkus point of view. It's the bits in red, so essentially the Java bits, as you might be able to guess. But if you go and take a look at Graal, you'll find, like I said, it's open source. You'll also find that there's a sub-project under their repositories called Mandrill. that is Red Hat's productized, hardened version of Graal. So everything that Red Hat does is, we take upstream communities, some of which, we drive, most others we just collaborate with. And when we produce a product, we have to, do full QE, hardening, stress testing, etc. And then any issues that we come up with, we push them back upstream. So this is essentially what Mandrill is. We take the relevant cut of the code from Oracle Labs, we pass it through our build suites. Any issues we find as we make sure that Quarkus works well with it, we push back upstream. But maybe because of process issues, they can't go directly into the main line of the Graal code base, at least immediately. They may get there after a few weeks or a few months, but we want to make sure that they're all available as quickly as possible. So that's essentially what Mandrill is, okay? But it's important that it's hosted in the Graal VM community because we don't want it to appear to be a fork. It's not a fork. Just conscious of the time, I'd like to make sure there's some time for questions and answers if there are some. But quick summary of the advantages and disadvantages of what Quarkus does with OpenJDK versus native. So as I said, you get like 50% memory reduction in that example where you just use OpenJDK. Really, the only difference that happens in the build cycle, if you've ever tried Quarkus, you'll know this. If you don't, hopefully this is going to be a quick one. Everything you saw about making the decisions at build time stays the same. That is immutable for whether you're using OpenJDK or then you move to Graal. The only bit is essentially at the end, before you get to the deploy stage, there's an invocation of Graal, and you compile down. So if you're just using OpenJDK, you still get what I was saying earlier, this advantage of millions of people hours of optimization of the language and the JVM, very high memory density requirements you'll get using just OpenJDK. Hopefully, you're all using a version of Java, hopefully mostly OpenJDK these days, but you'll know that it has evolved a lot over the years. So it still has really fast startup time. And if you let the JVM run long enough, and we're not talking about hours here, we're really talking about minutes, particularly on an application that doesn't change a lot, it will optimize itself a lot. It will do just-in-time compilation and keep those images. So it can get really, really fast, really good throughput with just OpenJDK. And that's how we saw, the raw performance or the startup time went from, I don't remember, 5 seconds down to less than a second. And the advantage that obviously the old adage of build once, run anywhere, that still remains with Quarkus if you're just using OpenJDK. When you go to Graal, you are compiling down. So you are, as with any compiler, you are making a decision based on the operating system and the hardware. So an x86 image is not going to work on ARM, okay? Whereas here, you don't care. You could take that Quarkus image and you could run it on a JVM built on ARM, even if you originally built it on x86. But you get much, much higher memory density. So we saw, the memory size reduced to 1/10 of what it was with the traditional approach. You get very, very fast request times and much, much faster response time as well. So like I said, there are pros and cons. Last thing I'll say, if it wasn't already obvious, clearly that use of Graal starts to put Java, because Graal is not specific to, well, it's not specific to Java. If you go and look at the project, they're doing stuff with COBOL and other things. But if we stay in the Java world, Graal is not specific to Quarkus. Other people use Graal. On the Java side of things, though, with Graal, that kind of puts your native images into the serverless arena. So you can, if you've used serverless, you can literally put a Quarkus application into a serverless environment, and you can know that when a message comes in and you have to fire up a response, something to do some work, and then fire back a response, that's typically what you'll be doing. You need that, milliseconds, tens of milliseconds at most response time, and that's kind of what you get. There are tricks you can play with serverless with this and with, your your traditional Java builds were having a farm of things running continuously, but that doesn't really help you with your costs. Just want to put quickly a graph of Quarkus growth from December 2020 to December 2022. This is Maven downloads, over 600,000 users a month these days, and I didn't get the most recent graph, which would obviously the curve is continuing up, so it's definitely hitting a sweet spot, and we're definitely seeing people use this more and more in kube environments in preference to the traditional way in building Java applications. So that was one problem, and how I think the community has come together and tried to address it. But there are other problems that are on the horizon that I want to touch on briefly. Some of these have solutions. Some of them have solutions that are in progress. In fact, I'd probably say all of them have solutions that are somewhere on that spectrum, from identified the problem all the way up to we think we've got a solution. And they include things like CO2 emissions. So Holly Cummins is in the back, and I know she gave her presentation yesterday on that, and I'm going to do a complete cluster of this when I try and do it in one slide. We got trusted content, and there are a lot of other environments that are coming up and have come up over the last few years that, almost like the problem we saw with Java prior to, let's say, Quarkus and Graal, could present significant problems to Java's adoption and use in these environments. And I don't think personally that they should present a problem. So this is my one slide for Holly's probably 60-minute presentation that she gave yesterday. Holly, do you want to come up and present this? So Holly, there's a link at the bottom which you can't click on because you're all in the audience and this is a static image. But Holly gave a presentation yesterday, but she wrote a paper and has given presentations over the last 12 plus months, I think, on how to write greener Java applications. And surprise, surprise, the size of the memory footprint and the time to start up something and also how long it can take to quiesce an application does have an impact on your CO2 emissions. And I don't know how many of you were here last year, but Martin Verberg, who works at Microsoft, I'm pretty sure it was DevOps last year, he gave a presentation about a number of things. And one of the things he talked about was how last year, I think Microsoft had announced this net negative CO2 emissions target. And Microsoft are the largest Java vendor in the world. Don't know if that comes as a surprise to many people, but through their acquisition of LinkedIn, which is all written in Java, and Minecraft, which probably isn't all written in Java anymore, but certainly the one my youngest son uses is still Java-based. They have a lot of Java. And then you throw in Azure, where they support Wildfly/EAP, WebLogic, WebSphere. The workloads that are running on Azure there's a lot of Java workloads there. So Martin was saying that generally this net negative target that Microsoft have is for everything in Microsoft. But because they have so much going on with Java, and I'm probably going to get the figures wrong, but I'm going to say it's hundreds of thousands of Java instances running on a daily basis. The eyes are definitely on Java and Microsoft to make an impact. So there's lots of things that they're having to do in OpenJDK, so they now have their own team, but also in frameworks, whether it's with Spring Boot or Quarkus, to try and minimize the impact that Java has. So this is not just a problem that, let's say, Red Hat has. This is a problem that anybody running Java anywhere, particularly in the cloud, has. And as Holly has presented far better than I have, something like Quarkus, where you're deploying it, or Graal VM based, where you're deploying it to Kubernetes and you can scale up and quickly scale back down when the work doesn't require it, helps you tackle that, rather than having your application server, your traditional application server, just running continuously and sitting there and waiting for responses, some of which may not come in for hours or days at a time. So a few graphs that I tried to expand a little bit from the slide that I got, but I think the one on that side, right at the top there, on the y-axis it says tons of CO2 per year, okay? And on the x-axis, requests per second. And the yellow line there, if you can't see it, is the legacy Java way of doing things. And then you've got the purple just below it is legacy frameworks. And then you've got Quarkus native is the blue one, and Quarkus JVM is the red one, which is interesting because I would have thought it was the other way around, but Holly has written all about this in there, and I'm not going to try and steal her thunder. Then clearly you've got your startup times down the bottom. So this is the CO2 emissions problem and how Java plays into it. It's been identified. We have some potential solutions, but this is not done. So this is something to be aware of. But Java, the people in this room, and the companies or the communities that you represent, we need to do more here. Otherwise, we will be in that same situation that I was talking about, a while ago about, well, maybe some other language can do this a lot better, and we have to get rid of that, get rid of Java and re-implement. And I think that generally that's not good for the industry. So the next problem I want to quickly talk about is secure content. So you may, depending on which country you've come from, you may be aware of various mandates from governments and certain departments in governments, like the US Department of Defense. I think the Swiss government, certainly in Singapore, they've made some similar edicts. But essentially what they are now rolling out are laws that require, either globally or for very specific sectors, that if they are using open source projects in their companies, they have to have very, very strong audit trails. Who built it? When was it built? Why was it built? How was it built? And the next couple of slides are going to kind of give you some background into why that was the case. But this is based on some reports from 2022, and the 2021 was a Sonatype state of software supply chain. And the stats come from there, so you can hopefully go away and find those and look at them yourself. But I don't think this is that much of a surprise, but 97% of applications are using an open source component these days. And I think that's phenomenal. Open source has kind of won, I think. 78% of application code is open source, and 73% year-on-year growth in open source downloads. Again, phenomenal statistics. However, there's the flip side of this. There is over a 700% increase in open source supply chain attacks. 84% of applications have at least one vulnerability from an open source project. 85% of applications contain open source components that are more than 4 years out of date. And some of those projects have no maintainers anymore. Those maintainers have gone. They may have gone and started to work in Go because they didn't like Java. Or they may be going back to COBOL. I don't know, but they're not there anymore. And a lot of companies that use open source software rely on the communities to fix things. Even as recently as last week, I think it was I seeing something from Dan Allen in one of the projects that he maintains? Some guy was saying, "Why aren't you fixing this for me?" And he said, "Well, you fix it. I don't do stuff for free. I have a career. I have to be paid for things." But lots of companies rely on free help. Let me put it that way, okay? And when those communities fizzle out, or the one developer that built it goes and does something else, who's going to patch it for you? I hate to make a Ghostbusters analogy, but who are you going to call? And I'm sure you'll have heard one of one or more of these things. Like log4j is probably the one that still stings a lot in everybody's minds. That's only like a year and a half ago now, but it still seems pretty fresh. So this is a big problem. And this and other things are the reasons that we have been pushed. We're seeing, like I said, those mandates from various departments and various nations to kind of make this a solvable problem. And essentially, you need to know what you are consuming. Hopefully, this is not not so that radical. Your tool chain affects your output. Your dependencies affect your output. What is it? The adage they say, is it like rubbish in, rubbish out, something like that. How can you trust your output if you don't trust your input? And if you don't care about what your input is or where it's coming from, you probably shouldn't be in this business in the next few years, because I guarantee you the consumer of your output is going to care and may actually take you to court. So again, there's a new set of rules coming up, I think US based at the moment, where they're literally talking about holding communities responsible for bugs and for CVEs that are found, no matter how long in the future. So you need to be able to tell others what you produce. Like I said, you need to be able to say what your build tools were, who built it, when it was built, how it was built, on what was it built. Because some hardwares could introduce issues in the build process that other hardware architectures don't. You need ultimately to convince others to trust it. I will also say, this is not a problem just for Java, okay? This is a problem that we have to tackle in Java, but as I said a few slides ago, this is a big open source problem that is gonna have to be addressed. And ultimately, because we're now moving so much to automated tool chains, we need to do this in a machine-readable way, in a non-reputable way, so that you have trust, and I may trust you, you may trust me, but that's not going to be sufficient in a few years' time, particularly if we go out of the picture. So you need a way to ensure that that trust relationship is represented in a manner that is independent of the people, the relationships that might still exist. So there's things like, so that SLSA I learned is called SALSA, or it's pronounced SALSA. So SALSA, in toto attestations, SBOMs, again, hopefully most people have heard of what SBOMs are, but these are just examples. There's a project called SigStore that is becoming very, very popular as well in this space. But it all boils down to this evidence of trustability. So I can give you something, and even if you don't trust me, you can look at it and go, I trust what is written down here. And you need to enforce guardrails to these policies. So we need to be able to check the metadata. We need to be checking, dependencies that might be brought in, and promoting builds through automated pipelines, taking the human out of the picture, and hopefully making sure that the pipelines are not, not vulnerable themselves. So, as I said, this is a big open source problem. But I did want to shine a light on one project in the Java space that is tackling this. And there are others, but this is hopefully one that many of you are aware of anyway. So there was a project called Adopt OpenJDK a few years back. It was Microsoft, it was IBM, Red Hat, London Java User Group, and a few others, essentially trying to provide a repository where people could go and get trusted builds of OpenJDK. It's not a competitor to OpenJDK. It's essentially a repository. That moved to the Eclipse Foundation in late 21, early 22, called Adoptium now. It's hundreds of millions of downloads at this point. Builds for all operating systems that you can think of: Mac, various flavors of Linux, Windows. All these new members are now involved. So Microsoft is now involved, Huawei, Google. And by involvement, some of them are involved in providing tests, helping to build patches, and other things. It's a big place for people to come and download binaries for OpenJDK. So therefore, and because OpenJDK is an open source project, therefore it is imperative that this group, this community, address those problems. There's another door. Okay. So what they have done is they've been working with SBOMs now for every Temurin build. They spent a lot of time last year understanding the problem and trying to address it. The Eclipse Foundation itself is trying to do this across the board. So it's not just Temurin specific, but clearly, as I said, because Temurin, which is the name of their OpenJDK build, is downloaded so many times a day, let alone a month, I think this is a critical one to show with this team. And they have reproducible builds, all automated. So I did want to touch on something else in the last 10 minutes, or the last 5 minutes if I possibly can, which is other environments that perhaps Java, a bit like Cloud and Kube a few years back, isn't necessarily thought of as being a player. And that's like IoT, AI, machine learning. I stuck up a quote from Richard Hammond. Hopefully some of you will know who he is. If not, go and Google him. But essentially, this is a quote he gave when he received the Turing Award. And what he's saying is that Newton was saying that his work was built on the shoulders of giants and trying not to to rebuild the world every time a physicist does something new. In computing, and this is back in the 60s, we tended not to do that then, and we tend still not to do it now. We often try and rebuild things and tell people, oh, you did it that way, but that's wrong. I think you should do it in a completely different way, and let's start from scratch and reset the clock and maybe get back to where you are in your language, but give me like 4 or 5 years. We did that when Java came along, and the popular languages at the time was C++. Probably in hindsight, it was the right thing to do, but we're still doing that today. And it's not just the Java community that kind of suffers from this. I think all language communities do. There are always flame wars about my language is better than your language. And I wanted to showcase this again, like I did last year, but not for the same reasons. So this is a project called Cruise Autotune. Cruise essentially uses AI and machine learning. It has a language model that has been trained based on all the best practices of JVM tuning that have been built up from IBM, Red Hat, and communities over the years. So it can automatically tune or give you initially the optimum parameters for the JVM, for the application that you're using, and then it monitors. And then it will change the next time you do a build of the image for Kubernetes. It will change those parameters based on what it saw, and again, based on the language model. So it's tuned, or its aim is for Java and Java developers. I think most of it is written in Java. It uses an AI machine learning model underneath the covers, which is not built with Java. It's using Python and Jupyter and all that stuff. But this is a great project in general anyway, but I wanted to showcase this again today because I think this is where we as a Java community can start to actually have an impact. Because I still hear from folks in my organization and also from outside that why are those people in the AI machine learning world, why are they using Python? They should be using Java. Java is far better than Python. Python's a shitty language. Shouldn't use it. Java is far better because this. Get over it. Look, there are other languages. Let people choose what language is right. But we cannot, and we should not assume that we can change those people's minds. Just as I would not want the Python folks to come in and say, you know what, you should be writing enterprise 3-tier systems using Python. That isn't going to work either. But I do believe that what I tried to show you just before with Cruise is a great way for Java community and frameworks to get involved in AI machine learning, because more and more people, whether it's with ChatGPT or was it Bard or whatever, they're going to start to want to understand how they can use these language models that have been built by some other group in a way that can actually be beneficial to them in their communities. And if we have to tell them, you have to throw everything out and start writing in Python and learn Jupyter notebooks, they're probably not going to do it. So we have a very, very rich community and lots of experience of using Java in other environments. And I think we can embed AI machine learning from these areas into our frameworks and applications. I do believe, from an AI point of view, that applications which don't use data like this for continuous learning to scale and adapt autonomously are going to be obsolete in the next few years, because we just don't have enough people out there to manage all the applications that are running on the cloud today. A lot of that is automated. And I think if we can inject AI machine learning into our Java applications and our Java frameworks, and hopefully existing ones, then we can give, by some definition of the words, better and more efficiently, we can provide that benefit to those communities. And I put up MicroProfile and Jakarta EE here because those are things that are also happening in the Eclipse Foundation. But I put them up not because I want to actually talk about them, because I talked about them way too much over the last few years, but again as a showcase for things that have been done in these communities and other communities over the last few years that I think are relevant to these, whether it's IoT, whether it's machine learning, whether it's other things coming. We have built up a lot of bulletproof frameworks and implementations of messaging and transactions and caching that we should work with these other communities to make them available to them. I'm sure that there are people out there in the AI machine learning world thinking we're going to build 3-tier systems on Python. Okay, maybe we can't convince them that they shouldn't do that, but maybe we can convince them they don't need to implement all these things that we've done in the Java world that do work. And with a nice shim of Python, if that even makes sense, they could use those and they don't have to implement them from scratch. So I think Java, the languages and the frameworks are continuing to evolve and addressing these challenges, but there are, changes needed in our development practices. Secure software is one. There's these other frontiers, AI, machine learning, IoT, where I do think there is a huge opportunity for Java frameworks and for standards. I put quotes around that because it doesn't have to be official standards. It could be de facto standards like are happening in the Eclipse Foundation with MicroProfile. But just somewhere that we can say, you know what, this is where you go for the Java SDK for ChatGPT or for Bard or whatever. And I do think there's a huge opportunity if we do it in a complementary, not competitive manner, for Java to remain influential in lots of different environments that would not necessarily have been thought of as being places that Java could play. All right, thank you. I've got 3 minutes left. If anybody has any questions, feel free to ask, or you can come up afterwards and grab me. We'll remind you there's these free JBoss Red Hat Party invitations here as well. All right, thank you very much.